So here we're going to talk about rational exponents. So basically when the exponent is a fraction, okay? So, so how to put those in exponential and radical form. If you have a real number x and a positive integer n, then if you have x to the 1 over n, that's the exponential form. And then the radical form will be this. So basically, this denominator here will become the index, okay? So for example, if I have x to the power of 1/2, okay, I write that as radical x, and then this is a 2, so it'll be a square root. Remember when there is a square root, there's like an imaginary 2 in here, okay? Or going the other way, if I have the cube root of x, this is x to the power of 1 over 3, okay? So that's how we can go back and forth with these. All right, so here, let's go ahead and put each in either radical or exponential form. So this is, I do a root. This denominator goes in here, so this will be 5th root of a. And here, this will be c to the power of, remember this is a denominator, 1 over 8. Okay, now, in all of the ones we did, the numerator was 1. But what if the numerator is not 1? What if we have a different numerator? Well, then, if you have b to the x over y, again, this denominator is always the index, but the numerator becomes the exponent of b, and that exponent can either be written inside the radical or outside the whole thing, right? So here we have exponential and radical form. So let's take a look here. If I have something like this, this will be the denominator, this will be the numerator. So this is going to be c to the power of -5 over 3. Okay, this is definitely not simplified form, but we're not going to touch it right now, okay? A, there is a negative exponent, and B, there is other things to do. We're going to go through and learn what to do with it in a little bit. Next one here. This is a denominator, right? So it'll be the index. So 4th root of d to the 7, or you can write it as 4th root of d to the 7 out here. How do you know which to do? Again, we'll do a couple of problems and you'll see whichever one is simpler, that's the way you do it, okay? All right, so now let's go ahead and evaluate these without a calculator. That's like every math teacher's favorite phrase, right? Without a calculator. So let's see what we do here. Okay, what is the first issue you notice here with this problem? It has a negative exponent, which is not cool. So this is going to be 1 over 49 to the power of 1/2. So first you get rid of the negative, right? Then this is 1 over 49 to the 1/2 is the square root of 49, 1 over 7. Okay? So remember, it's going to be a root, right? This denominator becomes the index, but if it's a 2, we don't write it. So it'll be the square root of 49, which is 1 over 7. Okay, now let's take a look at this one. No negatives here, so let's just do a root. Okay, so I have a root. 32 goes in here. 5 is the index. And now the 2, right? Where to put the 2? So one option is I put the 2 here, which means I have to do 32 squared, which is a god-awful number. So that's not cool. Or I can put the 2 outside. Now that will be much easier for me to work with, because when I do PEMDAS, 5th root of 32 is how much? 2 to the power of 2, right? That's such an easier thing to do. 4. Okay. Here, 8 to the power of 3 over 2. Okay. I'm sorry, 2 over 3. So this is the cube root of 8 squared. And the cube root of 8 is 2. Squared is 4. Okay. Here, again, I have a negative exponent. So I have to take the reciprocal. Yeah. Almost always outside. So I'm going to take the reciprocal of 1 over 25, right? So this will be 25 over 1 to the power of 3 over 2. Okay, right? Because you see a negative exponent and you almost, it's like debilitating. Like you can't even breathe until you fix that negative. Okay, now that we fixed the negative, I'm ready to move on. Okay, so this is going to be the square root of 25 cubed. Again, the square root of 25 is 5. Cubed is 125. Right? Fabulous. Okay. So let's go back to the issue of how do you know if your problem is simplified enough? Okay. So here's what you have to do. You have to make sure all of these conditions are met. First and foremost, no negative exponents. Like that is just not cool. Okay. Next. Okay, this is kind of confusing. No exponents that are not positive integers in the denominator. So basically, any exponent in the denominator has to be a positive integer. That means in the denominator, you can never have a negative number. You can also never have a fractional exponent in the denominator, okay? So all exponents of the denominator have to be positive and they have to be integers. Okay. You cannot have a complex fraction, so 1 over 2 divided by 3 over 2 or whatever, right? Oh my God, look at that bird. How cool is that? Oh. It's like, no, I don't need math right now. Okay. The index of any remaining radical has to be the least number possible. Okay? Huh? That was confusing. I will do one, and then when I solve that one, I'll tell you that was the one. Okay. Just go with me, Aiden. Okay. All right. Don't complicate things. Okay. All right. So here we go. Okay. So you see this problem, right? You're taking a test. You see it on a billboard, wherever. You see it. What is the first thing that comes to your mind? Right. Which means what? Use another word instead of combine. What do I do with the exponents? Add the exponents. Yes, we're going to combine them. And we're going to add the exponents. We're going to get 5 over 7. Okay, another thing that I guess I forgot here. Exponents can't be improper fractions. So that means I can have an exponent of 5 over 7, just not 7 over 5. Okay? All right, so that's it. We're done here. Whew, painless. Okay, let's do the next one. What is the first problem we need to fix? The negative 1 over x to the power of. Okay. Now, what is the problem now? There is a fractional exponent in the denominator. Any exponent in the denominator can only be an integer, okay? So how do I make, let me just give myself more room. How do I make this an integer? 2 over 3 is not cool. 3 over 3, that would be cool, right? Okay, 3 over 3 would be cool. So I can multiply this by x to the power of 1/3. Because it's 2/3, I have to add another fraction to this to make it 3 over 3. 2 over 3 plus 1 over 3 is 3 over 3. That is okay. So I multiply this by x to the 1 over 3, but I also have to multiply the top by x to the 1 over 3. So I get x to the 1 over 3, x to the 3 over 3, so that's okay. So I get x to the 1 over 3 over x. Okay, this exponent here is a proper fraction. That's cool. This exponent here is an integer. That's cool. No negative exponents. We're good to go. This step here, I just put it there to show you what we did. You can skip it. You can go from all this to this. Okay, now let's take a look here. There is a problem here. Okay, all these problems are problems. Okay, the issue here is I have a 6th root over here, but only a cube root over there. So I can't combine them into one root. I can only do that if the indices are the same. So how do you solve that problem? By writing this in exponential form. Meaning, I take this and I write it as something to the power of 1/6. Okay, but here is another thing. This is a 16 and this is a 2, right? Can I write the 16 in terms of 2? I can. It's 2 to the what? 2 to the 4. Okay, so why don't we go in steps? So this is technically 16 to the power of 1 over 6, 2 to the power of 1 over 3. We're good with that, right? But also, the 16 is 2 to the 4 to the power of 1 over 6, and then 2 to the 1 over 3. So now what do I got? 2 to the power of 4 over 6, 2 to the power of 1 over 3. So that's 2 to the power of 2/3, 2 to the power of 1/3. Now what do I do? You can subtract 2 to the power of 1/3, right? So I get cube root of 2. Okay. You can leave it. Usually when it starts up that way, we just put it back into the same form, but either one of these don't matter. 4 times 1/6 is 4/6. Okay, and then here we subtract it. Okay? All right. Okay, let's take a look at the next one. Okay, I have the 6th root of 2 squared and x to the 4. I'm just writing it as like a elemental base. So this is the same as 2 to the power of 2 over 6 and x to the power of what? 4 over 6, right? So this is 2 to the power of 1/3, x to the power of 2/3. So they both have a denominator of 3. That means they're both in a cube root. Cube root of 2x squared. Now, both of these are okay. Okay? So Aiden, this was the problem that we were talking about before. Remember how I said all indices have to be the lowest possible, right? So instead of a 6th root, we reduced it to the smallest possible cube root. You see, that's what it was. And we kind of did it here too. We had 6th and cube root, and we made it into a cube root. So that's what that meant. Okay. Okay. All right. Ready for another one? Yeah? I mean, listen, ready or not, it's coming. Okay, here we go. Here it is. Okay, what do we have here? Y to the half minus 1. In the last lesson, that would have been written as square root y minus 1, right? And how did we solve those problems? Conjugate. Multiply by the conjugate. Well, these also have a conjugate because they're the same thing written in a different way. So the conjugate of this would be y to the half plus 1. Y to the half plus 1. Okay, I'm going to do the denominator first. Okay, look at the denominator. I have something minus 1, something plus 1. A minus 1, A plus 1. Whenever I have that pattern, I do difference of squares, right? So I take the first one and I square it minus the second one squared, right? A squared minus B squared. Okay, the top we have to FOIL. So it's going to be, how much is that going to be, the outer terms? Y to the what? Y to the, it's y to the half times y to the half, y to the 1, because you add the exponents, okay? So it'll be y. I know, it's a whole new world. Okay, outer terms, y to the half. Inner terms, y to the half. Last terms, 1. Okay. Yes, it is. So y plus 2y to the half plus 1. This is so exciting. I love this. And then what do I get on the bottom? Y minus 1. Slay. Okay. What next? That's it. We're done. We're done.
It's so hard to know when you're done.
That's facts. That's what I said in the beginning.
Now I'm realizing.
Now you're realizing. That's what I said in the beginning, right? Now you know. Okay. All right. Okay. Sometimes you got to break out the vocabulary. Okay. All right. Whew. Ready for another one? Well, I mean, like I said before, it's coming. So, okay. So, what do we have here? B cubed, B, C, okay. Too many things. Okay. So, what do we do? So, you have, okay. So, look. What you want to do is you have to match like with like. Okay. So, I got some B's and C's up there. I got some B's and C's down here. You know what? Why don't I just sort this? Let's just sort first. So why don't we write as B cubed over B to the 1/3. I'm just writing the B's together. You can, times C over C to the 1/2. I really haven't done anything. I just like switched the order of the bottom ones, right? You can totally do that, of course. Because this whole thing is technically one fraction, right? Like this. And then, so the bottom, you can switch it back and forth. Okay. So I'm just, matching them up. So now look at the B's here, right? I can make this into B to the power of 3 minus 1/3. Right? Subtract the exponents. You guys know how to do this. Subtract the exponents. And now let's do the same with C. C to the power of what minus what? 1 minus 1/2. Do you see that? Look, I'm even separating them into different colors. Just divide and conquer. We're doing the B's separately, the C's separately. Okay. So what do I have here? B to the 2/3, C to the, oh no, it's 8 over 3. But you can't have improper fractions. So that needs more work.
Where did the 8 over 3 come from? Because you have to make the denominators the same.
It just made so much more sense if you were just like, I get it now.
But like Aiden says, you can't, okay, this C is okay. C to the 1/2 is cool. This is not okay. So So how do we do that? Okay, so let's go on our scratch paper for the b. Okay, you don't have to write this or, okay, so look. B to the 8 over 3, that's really cube root of b to the 8, right? And what were we doing before with that? We were doing 8 over 3 and then, you remember 8 divided by 3 and then the remainder stuff? Okay, so that's what we're going to do here. So look, 8 over 3 is what? 2, remainder 2, right? Yeah, 8 divided by 3 is 2, remainder 2. So this is going to be b squared cube root of b squared times root c. Okay, let me add another step in here. Okay, stop. Let me add another step. Why don't we write this as cube root of b to the 8, like it's like in the next lesson, last lesson, and then this is root c. Okay. Now, so remember we were doing 8 over 3. That's 2 root 2. So what will this blue turn into? B squared cube root of b squared, and then times the root c. So that is your final answer. Okay? Cool.
So if you change one root out, we have to change the whole thing. Like you can't have one.
Wait, say that again and then I'll take you. Say that again.
Like you can't change one to radical to see half.
There is nothing illegal with it. It just looks weird. It's like having fruit in your salad.
You don't like fruit salad? You don't
Well,
like
that's
fruit
a
salad?
fruit salad, but it's not like right. Well,
Nah, that's not it.
Oh my god, Chinese chicken salad.
see, I don't do
No,
that,
that's not-
and I don't mix my exponential and radical forms.
I take it out.
Okay.